Welcome back to College Algebra, and you are in the series where we're talking about the basics of college algebra. In this series, we're talking about how to work with decimals. Today, in particular, we're talking about multiplication with the decimal numbers. So as we normally do, we'll start this lesson with a problem, and hopefully through this problem, we'll discover a little bit about how to multiply with decimals. A few notes. We are going to introduce a very nice rule, a rule that you've probably heard before, and we're going to refresh you on and you can use again in the future. But I want to do something more important, and that is I want us to think about why that rule is true. Because memorizing rules is temporary and fleeting, and you've probably memorized rules before, and what happens is over time you forget them and they go away. But if you understand the reason for the rule, if you understand why the rule is what it is, then that stays with you. And so if someday you forget the rule, you can still understand the ideas behind it, and you can still work your way to understand the problem. So let's start with this problem, where we have 0.1 times 0.01. And the question is, what are these two things? Well, what I would say when I read this problem is that I interpret this as 0.1 is 1/10. And we talked last time about how 1/10 is, if we have ourselves a number line, 1/10 is 1 out of 10 spots in a number line. Or in other words, if we took like a single block, 1/10 is 1/10 of this block just shaved in a little piece. 1/100th would be what we get if we shave this block into 100 pieces and just take a tiny little piece of it. So this is 1/10, and this is 1/100th, and so I would interpret this problem as saying what is 1/10 of 1/100th. Okay, now let's think about how we answer the question. I think you all probably know what we should do, and that is I would stack them on top of each other, and I would put 0.1 and 0.01, and I would write multiply, and then I start writing things down. So 1 times 1 is 1, and now we have the 0 here, but the question is, where does the decimal go? Where does that decimal point go? Is it going to be 0.1, 0.01, 0.001, 0.001? So the question is, where's our decimal point go? And that's what we have to figure out with this problem. My answer is, the best way to think about where that decimal point goes is to think about what these numbers actually represent. And that is the numbers representing 1/10 and 1/100th. So let me come over here and get this picture that looks kind of familiar from the other day. And what you should think of is you think of this big green block as representing a zoomed in version of one of these green blocks. So this big green block is 1. And so if this is 1 unit, what I've done is divided it up into 100 different pieces. I was a little bit generous to make the piece I want to talk about a little bit bigger than the others. Ideally, they would actually all be the same size. So what I've done is I've taken this piece and divided it into 100 pieces. And so this orange square down here in the corner is 1/100th. Now what I want to do is I want to take 1/10 of that. So I'm going to grab this piece and I'm going to draw 10 divisions to divide it into 10 parts. So there you have it. I have taken that problem and I've taken that block and I've split it up into 10 pieces. I just drew 10 lines straight down the middle. And now I have 10 pieces making up this 1/100th block. So what is 1/10 of 1/100th? 1/10 of 1/100th might be this strip right here on the outside edge. And so this strip right here is 1/10 of 1/100th. And the answer is, how many of these little purple pieces would it take to make up a full 1? The answer is we would need 10, and then we need 10 more, and 10 more, and 10 more. And the answer is we have 100 sets of 10, and so you multiply 10 by 100, and I think we know what the answer is. The answer is 1/1000th, or 0.001, because that's how we represent 1/1000th. So the question, to our earlier question, when we ask, what do we get when we multiply 0.1 times 0.100, the answer is we have 1/10 of 1/100th. The answer is we get 1/1000th, 1/1000th. And so this decimal point should be placed in the third spot right here. So it should be 0.001 because we get 1/1000th. Now there's a quick rule that we can follow, and I'm going to go ahead and tell it to you, even though I want us to not become so reliant on the rule that we stop thinking. But the rule is just this. It's just that when multiplying together, when multiplying decimals, add together the total number of decimal places in the two numbers to get the number of decimal places in the answer. So let's look at how that compared to what we just did. And what you'll see is we had 1 decimal place in the first number, we had 2 decimal places in the second number, and so the amount of decimal places in our answer is 1, 2, 3 decimal places. So we moved 1, 2, 3. So we move our decimal 1, 2, 3 places to the right. This is our rule, and if you remember this rule, you will get the correct answer, but as I said before, I don't want you to rely on a memorized rule that doesn't make sense. I want us to think about why this answer makes sense. The explanation I just gave is one good reason. It's because the number of decimal places in the first number tells us how many pieces we've split the number of decimal places in the second number into. So in this case we have 1/10 of 100th, so we split 1/100th into 10 places. That means we now are dealing with 1/1000th. You can see this idea should generalize if you had, say, 3 decimal places and 5 decimal places. Then you've split it where you'd have 8 decimal places. So this is the basic idea, and we'll go talk about some other problems, but always lean back on that same basic idea. Let's look at another problem which isn't too far of a stretch from what we just did. And it's the idea of 0.04 times 0.8. And we could probably do this. I would write something like this. 0.04 times 0.8. And what I would write down here is I would have 8 times 4. We all know the answer is 32. So I should put 2. Usually we carry the 3. I'll go ahead and carry it just for completeness sake. And you see we get 8 times 0 is 0 plus 3 is 3. You can see right away that the answer should have been 32. So it's 32, but it's 32 whats? Well, you notice here we have hundredths, and here we have tenths. So we put tenths and hundredths together. So it's like we had 4 tenths and 8 hundredths. So we take each of those 8 hundredths, split them up into 4 parts, and so what we really have is 32 thousandths. And so we have 0.032 as our answer. So when we see this, we see 0.04 times 0.8 is 0.032. You notice our principle still held when we solved this problem. Our principle held that we had 1, 2 decimal places plus 1 decimal place is 1, 2, 3 decimal places. And so our answer has 1, 2, 3 decimal places. You compare this to the last answer, and you see that we have we did the same thing. We had the 0.1 and the 0.1, so we got 1,000th. Now we have 32,000th. Because what this 0.04 means is it means we have 4 hundredths and 8 tenths. So our hundredths and our tenths are still being multiplied together to give us thousandths. The only difference is we now have a group of 4 and a group of 8 giving us 32 of those thousandths. So that's how we're going to think about things. That's how we're going to put these problems together. And now we'll come to a problem that puts these together in a more traditional looking problem where we have a bunch of things going on. We have 3.54 and 1.8 times 1.8. Now, let's start working on this. How I would do this is just like traditional multiplication, where you multiply the first number by everything, and then we come down to the next line and multiply the second number by everything. But I'm going to do a little annotating because I think that's going to help us. So notice we have 8 times 4 is 32. So that's going to give us a 2 here, and we're going to carry the 3. But my question for you is, what is this 2? What type of number is it? Well, the answer is, if we look at what we just did a moment ago, if you ignore everything else, you notice what we happened is we took 4 hundredths and we took 8 tenths, and we multiplied hundredths and tenths together. So this 2 is actually a thousandth. Oh. Sorry, I struggle with both writing and spelling, so sometimes things get a little messy. But this number is a thousandth because we took hundredths and tenths and combined them, and what we got for our answer is thousandths. Now, when we move over to our next digit, we get 8 times 5 is 40, plus 3 more is 43. So I'll put a 3 here and carry my 4. And then I ask, what is my next digit going to be? Well, my next digit, I put a tenth and a tenth together, and so tenths and tenths make hundredths, because a tenth of a tenth is a hundredth. So notice that my next digit here should be a 100th digit. Finally, we put this 8 and this 3 and multiply them together, and we get 8, 16, 24, plus 4 more is 28. And so we get 8. Could carry the 2, but let's just write it right here. And now let's ask the last question, and that is, what should this last digit be? What is this 8th digit? Well, we have a 10th and a 1. So if you just take your unit and split it into tenths, then we get tenths. And we get our tenths digit. And so what you see is that our multiplication has yielded thousandths here, hundredths here, and tenths here. And so you might be able to guess, and I could go ahead and write it in the problem if I like, that our decimal place is going to be placed right there in the second number. Notice this still follows our principle. Our principle is when multiplying together, we take the total number of decimal places, which is 1, 2, 3 decimal places. There are 3 numbers to the right of the decimal, and we add them together to give the total number here, 1, 2, 3. So we get our 3 decimal places. But really the answer comes not because of some magic rule, it comes because that's what happens when you combine decimals with other decimals. If you combine tenths and hundredths, you get thousandths. If you combine tenths and tenths, you get hundredths. So this is how combining numbers works. Okay, now let's come here and do the second line and see what we get. The first thing we're going to do is we're going to multiply 1 times 4 and get 4. But the question is, what are those 4? What are those 4 things? Let's keep our space here where we were. Let's ask, what are those 4? Well, we have a 1 and a hundredth, so we've taken our units, split them into hundredth pieces, and so this 4 actually falls in the hundredths column. And notice this follows what we always did with multiplication. We always put a little space. I always write a 0 here so that I don't get distracted, but you could leave it blank. It doesn't matter. But you'll remember this from when we did multiplication long ago. But the real reason is because we've taken hundredths and units and gotten hundredths left. Now our next one, we'll take 1 times 5 and get tenths. And the last, we'll take 1 times 1, 1 times 3, units times units, gives us units. And so as we look at the problem, we see that I have now aligned everything up so that I have a thousandths column, I have a hundredths column, I have a tenths column, and now I have a units column. And so when I add these together, I can get my answer, which is 2, 7. See, this looks like it's 13. I need to carry a 1, and it looks like I get 6.327 as my answer. And as I look at this, I can see where the thousandths, hundredths, and tenths go. And so I can read through this problem and see my different labels. Okay, now that we've solved this problem, I want to think about it one more time, and this is a different way of considering why we should follow our rule of adding together the decimal places, 1, 2, 3, to give us the number of decimal places in the answer. Some people this rule fits a little better with. I tend to think of it as dividing divisions, but some people this sits really well with. And so I'm going to tell it to you and see if this makes more sense than the other. So one way of thinking of the number 3.54 is to think, what is 3.54? 3.54 is actually the same as 354 what's? Well, it's 354 hundredths, or 1 100ths, so times 1 100ths. So 3.54 is actually the same as 354 hundredths. And what is the number 1.8? Well, 1.8 is actually the same as 18, but 18 what's? 18 tenths. So notice that if you have 1.8, you've added together 18 of our little tenth units. So that's given. So 10 of those tenth units gives us the 1, and the other 8 give us the 0.8. So this is 1.8 tenths. I guess I shouldn't have been lazy here, so I'm going to finish them. Okay, so we have our hundredths and our tenths to look at. And so now if we do multiplication, what you see is that if we multiply the 3.54 and the 18, you get the same multiplication that we had earlier. So take 354 times 18. We get the same 2, 3, 8, 2, 0, 4, 5, 3. These numbers would have came out to be the same calculation that we got over here. Then you end up with 2, 7, 3, and 6. So we end up with, so when you multiply 354 times 18, we end up with 6,372. That's the answer we get when we multiply those two together. But the question is, there's 6,372 what's? Well, we've already talked about it. When you combine hundredths and tenths, what do you get for your answer? Your answer is thousandths. The answer is when you combine hundredths and tenths, you get thousandths. So this thing is times 1 over 1,000. You can also see, and we'll talk a little bit more about exponents in the next section of basic lessons. But when you combine 1 over 100 times 1 over 10, you get 1 over 1,000. And that kind of makes sense if you think about it. So what should our answer be? So our answer should be this number that happened when you multiplied the two numbers as though they were whole numbers. So our 6,372, so when you multiply them without decimals, it's this number, except what are they? They're thousandths, so that means we have to put our decimal place here in the third spot. And so what you see is that we got 2 decimal places from the first one, 1 decimal place from the second one, and they combined to give us 3 decimal places in the end. This is another way of thinking about the same problem. At any rate, the principle follows the same, and if you remember the strategy that we had at the beginning, which is when multiplying, we just add together the total number of decimal places in the two numbers to get the total number of decimal places in the answer. This works, but again, I don't want you to be so reliant upon memorizing this formula that you stop thinking about why the answers work the way they do. Let's finish today's lesson as we do mini, and that is with a couple example problems. I'm going to have you pause real quick, so take a break, try these problems independently, and then come back in just a few minutes and we will see if we can get the correct answers. Okay, well, thank you very much. I'm glad you tried it, I hope. And we'll start by looking at this problem number A and see what we get when we try to solve it. And so when I try to solve problem A, I would write them horizontally, write them 1.02 times 0.7, and I would write the line like this. And this is multiplication like always. And I would do the multiplication as though these were digits without any decimals in them. That is, I would do 7 times 2 is 14. Let's carry the 1. 7 times 0 is 0. We'll get the 1. 7 times 1 is 7. I'll put my little spacer here so I don't get too disoriented. I could put a whole line of zeros. Maybe I will, because 0 times 2 is 0, 0, and 0. Now I'll put 2 spacers in that row. Notice I could have skipped that whole row altogether. If you did, that's fine. Now we'll do 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. So as I add these together, I have 4, 1, 1, carry the 1, 1, and 2. So the digits I got are 2, 1, 1, 1, 4. That's what we get when we multiply 102 and 2.07. But the question is, where does the decimal place go? And the answer is we have 1, 2, 3 decimal places, so the decimal goes right here in 21. So it's 21.114. I want to say something, and that is you could probably, on most decimal problems, if you stop and think about it, you could probably guess where to put the decimal place without using any rules. Why is that? If I look at this problem, I notice that this is about 1, and this is about 20. If you multiply 20 times 1, we'd expect our answer to be about 20, right? In this case, 21 is pretty close. 211 would be way too big for multiplying 20 and 1. And 2 would be way too small for multiplying 20 and 1. So you could probably guess your way to the correct answer if you wanted. But it's good to always have some kind of stronger reasons for why we should get our results. A few notes here. Like I said earlier, if you had completely skipped this line, that's no big deal, but you have to make sure to get this 4 in the correct column, and that's the third column. The reason why it goes in the third column is because what is this column representing? This column is representing tenths, and we have a 10 and a hundredth, and so if you put 10 hundredths together, if we take our little picture here, if we put if we put 10 of these hundreds together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 hundredths together, then you get a tenth. You get one whole column. So 10 hundredths is the same as 1/10. So this should be the 10th column. Similarly, if you look at this final row, the 2 times or look at the first row, the 7 times 1 is a 10th times 1, and so the 10th column is where those should go. Okay, let's move now on to the second problem, and we'll do 0.79 times 0.005. And so I will write these on top of each other. 0.79, 0.005, and let's multiply these together. And as we multiply them together, we'll do 5 times 9 is 45. Carry the 4. 5 times 7 is 35. 36, 37, 38, 39. And 395 is what we'd get for the answer. The question is, how many decimal places do we have? And the answer is we have 1, 2, 3, 4, 5 decimal places. So we have 1, 2, 3. We need to create more spots because we need to have 5 decimal places altogether. And so we need 1, 2, 3, 4, 5 decimal places in our answer. So it starts out 0, 0, 3, 9, 5. If you thought about this, this is because we get 2 decimal places from the top, 3 from the bottom. Okay, I hope those problems went well for you, and I wish you good luck on the homework, and I'll see you next time when we talk about dividing decimals.